Dear students, now I am going to discuss about the topic that is ethanol from a biogas. So how the ethanol is produced and where it is used. So this topic belongs from the subject that is the renewable energy sources. So here in the production of ethanol from the biomass, we consist of mainly three sources. That is one is the sugar, another one is the starch, then next one is the cellulose. Here from that sources we can ethanol is fermented, sorry, sugar, the top material sugars or starch that is fermented. We can, after the purification, the ethanol is produced. Then after the ethanol production, it is blended with the conventional petroleum products in a 5% 10% that is transported and then used as in a petrol station. So this is the application of ethanol. This one deals with the what are the sources that are available for the generation of ethanol. Let's discuss one by one in detail. Okay, listen. Here, so ethanol from biomass, its ethanol is ethyl, other name that is called ethanol alcohol, that is C2H5FH, that is a colorless, flameless liquid. It is a flame, there is a colorless, flammable liquid. It is from a renewable energy source because it's generated from biomass and it can be substituted as a petroleum product. So in nowadays you can use that is called as a E5, then E10 in some of the petrol supply stations. That is the mixture of ethanol or blended of ethanol along with the conventional petrol. So ethanol can be produced from the variety of biomass materials that contains the three major sources: starch, sugar, starch, and cellulose. So the best known feedstock for these three categories, there is the one is sugar, then next one is starch, and the third one is the cellulose. So in a starch, so first one in the sugars, the best feedstock for the sugar is sugar cane, sugar beet, sweet sorghum, grapes, and molasses. Here, the this are made up of, say, that is called as the monosaccharide compounds, that sugar cane, sugar, and etc. So it's having the chemical compound that is called the glucose. The glucose is directly converted to ethanol with the help of a fermentation. Otherwise, there is a component present is that is called as the yeast. The help of is directly converted to ethanol. But in the second category, then first this is the first category. In second category, we are having a starch. The starches that starch compounds are available in the maize, wheat, barley, potatoes, cassava, and rice. This having a large amount of starches. Here, the starch is converted into ethanol via three process because starch is somewhat difficult to convert directly into ethanol with the help of fermentation. So first we move with the hydrolysis. Starch is converted into maltose. Then after the hydrolysis, maltose is converted into glucose. Then after fermentation, the glucose is converted into ethanol. Then third material having that is called as a cellulose material. The cellulose material normally available in the wood, straw, stems of grasses, bamboo, so canbacazine, etc. Here, the cellulose is first initially converted into glucose with the help of special hydrolysis process. Then after the glucose, it moves to the ethanol with the help of fermentation process. So all the three major sources: sugar, starches, and cellulose. So these they are finally converted into ethanol. Okay. Now we discuss each process one by one. So first process, that is a production process from sugars to from sugar to ethanol. Here the sugar rich crops that are already find, that is sugar cane, something foods and etc. Here, the sugar which contains the valuable raw material crystal sugar and byproducts from the sugar mill is called as a molasses. The molasses that is contained, that is a 50 to 50 percentage of sugar content. Here, the basically the sugar element that is made up of the chemical compound that is called the glucose or fructose, each having a same chemical from C6H12 and O6. So that is monosaccharide form of sugar that is easily breakable. Here, then sweet fruits like grape, mangoes, and etc. contain a glucose in a natural form. So every fruits having glucose in a natural form. So juices containing sugar can easily fermented into ethanol. The sugar is easily converted by adding yeast. Yeast is nothing but one of the there is an enzyme. Yeast are called that is called as a microorganism. That microorganism that is called bacterial microorganism, which called as Saccharomyces cerevisiae. So which helps for the converting then glucose into that is called as a ethanol. with the help of the yeast. Okay. So molasses, that is a already know that is molasses a byproduct of sugar, that is compromise of a glucose, sucrose, and fructose, which are converted into alcohol with the help of say fermentation process. So this process is known as called as a fermentation process. From converting direct glucose to ethanol with the help of yeast, this is called the fermentation process. Normally, 1 ton of sugar can with an average sugar content of 12.5% yields 70 liters of ethanol by direct fermentation of juice. Here you're having a sugar cane juice, then sugar cane juices directly undergo the fermentation. It can produces the ethanol. Okay, but next one, the byproduct sugar cane that is equal to molasses. Here molasses also able to produce a ethanol, but 1 ton of molasses nearly that can produce 230 liters of ethanol. Directly fermented sugar cane juice yields much higher ethanol when compared to molasses because here 1 ton of sugar can yield that is almost yield 40 kg for that may be 40 kg of molasses. So for 1 ton of molasses, then 1 ton of molasses we almost need around for 40, sorry, that may be approximate from 30 to 40 kg of molasses. Approximately have 25 to 30, nearly it is equal to 1 ton of molasses radical 25 to 30 tons of sugar cans. So 1 ton of molasses, which that can be produced from the 25 to 30 ton of sugar cane. So 1 ton of sugar cane yields 70 liters. So almost approximately consider 30 into 70 liter, almost we are getting 2100 liters for 25 to 30 ton of sugar cane. There is 2100 liters we are obtained. But the molasses obtained from the 25 to 30 ton of sugar cane is a 1 ton of molasses. 1 ton of molasses can able to produce the 230 liters of ethanol. So there is a difference. So the direct conversion of sugar cane into ethanol is a more advantageous, but it has a drawbacks. That is, what are the drawbacks that are here is mainly because of food versus fuel issue. So primarily we mainly concentrate on food, then next to the fuel. So the sugar cane that is first used for food purpose and then next is used for a fuel purpose. Then second process, there is a product starch to sugars. Earlier I told, so it is difficult when convert starch into sugars when compared to the starch. Difficult to convert a starch into ethanol when compared to this sugar into ethanol. Why? Because this. So this is made up of disaccharide form of sugar. It is a complicated structure having many glucose molecules linked to her along a long chain that is called as a disaccharide. So disaccharide. So fermentation process is not suitable for converting disaccharide form of sugars into ethanol. So for that, it needs some process prior to the fermentation. So what type of process that is used? So that process is called as a hydrolysis. Here, the yeast culture cannot convert the starch into fermentable sugar. So starch into sugar is not possible. So here is starch not directly converted into sugars, then sugars to what? Ethanol. So some intermediate here the fermentation is not possible. So here fermentation is accepted, but here the fermentation is not possible. Here fermentation is possible, but here starch to sugar we need a process that is called as the hydrolysis. So the starch is converted into maltose. Then maltose is again converted into that is called as a sugar. Sugar compound that is called as a glucose. So conversion can either done by hydrolysis of starch with the dilute sulfuric acid through the enzymatic method. Here there is a not fermentation method is not applied. Here the enzymatic method is applied. So first starch having the chemical formula that is C6H10O5 that is the N. Starch is converted into maltose by means of hydrolysis process. Then maltose is again converted into glucose by means of hydrolysis. Then after that glucose that is form of that is called as a sugar. Sugar is converted into what? Ethanol with the help of fermentation process. So here the two prior process before to the fermentation is employed for converting starch into glucose with the help of enzymatic method because it is a compound that is made up of disaccharide. Then next process, the production process from cellulose to ethanol. So previously we discussed it as sugar to ethanol. Next one is starch to ethanol. Now it is cellulose to ethanol. Here, the cellulose is material that comes from dry biomass abundantly available, but it's difficult to utilize the carbohydrate in a cellulose. So it's a one difficult form. Here, the cellulose which is available in the wood, grasses, crop dust contain a long chain of sugars. So previously, starch also having a long chain of sugars. This is also cellulose also containing a large long chain of sugars. And lignin available in the plants which hinders the hydrolysis to the sugars. So in the previous cases, note that starch is converted into sugar. That is, sugar is nothing but there is a glucose with the help of process hydrolysis. Sorry, hydrolysis. But here lignin available hinders the hydrolysis to the sugar. Hinder means that it stops the hydrolysis to the sugars. So why? Because this complex material is called as a polysaccharide. So earlier one, starch it is having a disaccharide. Cellulose it is a polysaccharide, which is the chemical bond of cellulose is not as easy that a starch to the simple sugars. So the conversion process is somewhat difficult when compared to the starch to sugars. So the conversion of cellulose material is carried with special hydrolysis. So it is normal hydrolysis is not available. There is special hydrolysis with the dilute sulfuric acid at high temperature around 180 to 200 degrees Celsius. So previous two process requires doesn't need a high temperature, it requires a room temperature, but this special hydrolysis process requires the high temperature around 180 to 200 degrees Celsius. That causes product of sugar to decompose into glucose. Product sugar that is into there is a cell glucose here. There is a cellulose. Um, Here there is also there is the same element as a starch, but there is a different in chemical composition. Here the starch with the special hydrolysis it can be converted into glucose. That glucose is nothing but that is the sugars. Then after that sugar that is a glucose so which is converted into ethanol with the help of fermentation process that normally kept at a room temperature. So glucose production achieved adjusting three variables: acid concentration, operating time, and reaction time. So this is the acid concentration which there is dilute sulfuric acid is used. Then the reaction time and reaction temperature. Reaction temperature is 180 to 200 degrees Celsius. So reaction temperature and acid concentration are major factor for determining the optimum glucose production. So from the glucose production, we directly move to the ethanol as like a process available in the first case that is a sugar to ethanol and the second case starch to sugars and ethanol. Okay, then we move to the next slide. So here then the ethanol is produced from the fermentation process. Here some content that should be maintained. There is a 10% concentration maintained as a fermentation process. So some microorganism in the yeast is poisoned. So we have to maintain the concentration as optimal level for the ethanol production. So concentrated ethanol can be increased to 95% volume by successive fractional distillation. So we can after the fermentation process, the ethanol concentration is moved to the 95% volume with fractional distillation. This product is hydrated ethanol. This can be directly used in the modified IC engines. Now, the removed 5%. So, from the 100 is a 95 is, that is called as hydrated ethanol. Remove 5% of water is difficult to remove by simple distillation process. So, complex distillation that is to be required because it is the this is called as the because it's called there is azeotrope. Azeotrope is having a same chemical formula that's contained liquid as well as a vapor. So which prevents a separation due to absence of differential vaporization because there is a difference in vaporization temperature. So it's difficult to separate it the 5% of water. So here this anhydrous ethanol is produced with the azeotrope removed by water by co-distillation. Here the co-distillation is the first one is called as a fractional distillation, and after one is a co-distillation using benzene as a solvent. From that, from the this co-distillation process, we are getting there is a 99.9 percentage pure ethanol is obtained. So this is given in the figure. This figure consists of all the three processes. Here, in the first process, there is a natural sugars. So natural sugars that is having a glucose. So glucose is directly converted into sugars by means of what process? That is called as a sugars. That is glucose directly, sorry, sugars. That is form of chemical. That glucose is also called as that is sugar. Then sugar is converted into ethanol by the fermentation process. So here this component is called as that is called as a monosaccharide compound. So that is easy to break. So this having a formula that is equal to C6H12O6. That is a form of there is a glucose. Then next one there is a starch. This is can be this can converted first one the sugars can convert into fermentation. Sugar to ethanol that takes only one process. Here the starches, then starches that's having a compound that is called as a disaccharide. It is a long chain of sugars, so it is difficult to break. So that's having form that is equal to that is a C5, C6, then H10. Chemical formula is equal to C6H10O5. O5 that can be moved to the hydrolysis. Then hydrolysis we can obtain the component that is called as a maltose. Then after the maltose that can again move with the hydrolysis. Then we are getting a sugar. Then sugar is moving to the fermentation. Then we are getting ethanol. Then third one is called as a polysaccharide compound. So polysaccharide is a cellulose. So this having a same structure that is equal to C6, H10, then O5. But there is a difference in the chain structure. Here it is represented by means of uh, starch can represented by means of 2 into N. Here that can be N into C6H6O5. This can have different hydrolysis in the presence of this called acid that is H2SO4. Here also sulfuric acid, so diluted sulfuric acid is here the diluted sulfuric acid because here the temperature maybe takes place between 180 degrees Celsius to that is 200 degrees Celsius. So the difficult hydrolysis is involved for breaking the cellulose to sugars. So in a process one, in a raw feedstock material, we consider there's a one, that is a two, that is a three. We have a three feedstock material. So the three feedstock material finally is converted into sugars. But in first material, the already existing component is that is sugar. Then sugar is converted into that is ethanol. Sugar is converted into there is a 10 percentage ethanol by means of that process called fermentation. So fermentation is common for all the three feedstocks. After the fermentation, we get the 10% of ethanol. So this 10% can be improved to 95 percentage anhydrous ethanol by means of fractional distillation. So after the fractional distillation, the excess quantity of 5 percentage that is removed by means of that is called a special distillation. So in special destination, we are getting 99.7 anhydrous ethanol blended with the petrol. This is the final product that we got. So clearly note that we have a three feedstock. So first feedstock directly glucose already it's having a sugar compound. So by fermentation, it can move to ethanol. But in second case, there is a starch. Starch is converted into that is called a sugar, and then there is a ethanol. This is it involves two process. Then third one process cellulose again it is converted into sugar and then ethanol. There is a third process. So almost process two and three are same, but in two process we are getting a maltose. In hydrolysis process we are getting maltose. Here in a process three in a hydrolysis process we are getting sugar, but a special hydrolysis required. Okay, now that is ethanol as a fuel. In anhydrous ethanol, there is a 10% is blended with the petrol and 90%. So in our petrol pump, we are getting E10. That is that combination is involved here, eaten without any engine modification. We directly use the ethanol along with the petrol. So ethanol is more or less similar to the gasoline because it's a higher octane rating. So that's why it's having a better anti property. So because of higher acting octane rating, ethanol is blended with the petrol. Petrol also having a higher octane rating, but diesel it is C10 rating here. So there is a difference in the petrol and diesel. So in Canada and Sweden, we have 10% ethanol blended petrol issues. In India also. In world leader in the production of ethanol is Brazil because the world leader in the production of sugarcane is Brazil. So that's why Brazil produces a large amount of ethanol. Here using 25 to 26% is blended with the petrol in the conventional vehicles. Here in India, it can produce 18 tons of per year of sugarcane is produced, ensuring ethanol of 1,700 million liters. But in 1,700 million liters, 1,200 liters that will be consumed by the chemical sector. So remaining 5 million sector liters are available, which is sufficient for 5% blending along with the petrol in our country. So already we achieved a 5 and we moved to the 10. Then molasses is reduced of sugar factory, which is having a 40 to 40% sugar, cannot be obtained from the conventional methods. There is a drawback. So, but molasses are fermented with the yeast. That is the same enzyme that is used in the first process from uh, sugar to ethanol. That is fermentation. That fermentation enzyme. Then the alcohol is obtained with the separate way distillation column. So we can produce ethanol from sugar as well as a molasses. So molasses same process like a sugar. But in Indian condition, we are producing 230 liters of from Montana molasses. Already we discussed in the first slide. Ethanol is a 6 times higher than the higher for sugarcane is directly fermented from the molasses. So if you're getting 230 liters of ethanol from this molasses is equal for the molasses we obtain a sugar from that sugarcane we almost get around 1,500 liters of ethanol where the feather the sugarcane juice is directly fermented without molasses. So this 1 ton of sugarcane can use 13 percentage of sugar is a 70 liters of ethanol. That is we already discussed. So from for using 1 ton of sugarcane we are getting almost 40 kg of molasses that we obtain. So from that we are also getting a ethanol. Okay, thank you. So so this class that we discussed overall be about the production of ethanol from the various biomasses through the fermentation as well as the hydrolysis process. If you have any suggestions regarding this video, please your suggestions in the comment box. Thank you.